Welcome, everyone. We are glad to be here today with Jack to present you the progress of our project. I'm Vincent Le Breton. I'm the project manager on this project.
And my name is Jacques Robert, and I am a chemical engineer specialized in water treatment. And I work at Veolia company for 20 years, about 20 years. And actually, I work as a process engineer for Veolia Nuclear Solutions.
Together with Jacques, we are going to explain the story of this project, which is which consists of installation of a system to extend the life extension of the nuclear power plant in France. So first, we're going to make a short sum up of what we are doing at Veolia Nuclear Solution, and then we're going to go into detail into the presentation. So first, Veolia Nuclear Solution is the subsidiary specialized in nuclear activities for Veolia. So we do characterization, retrieval, everything along the cycle of the treatment material and effluent treatment. As you can see, we have also the ability to do measurement in our lab and to do a vitrification process. If you wish to learn more about vitrification, I suggest you go on in our booth J41. Next one. So VNS today it's about 600 people. We are located in 4 main areas. So United States, France, UK, and Japan. Our team is comprised specialists, engineers, and of course trained technicians and support staff. Our ambition is to continue to grow in our field of expertise and also to develop other territories on which our offer is on demand. For instance, vitrification, formal water treatment, waste management, and so on. So let's get back to the water treatment issue. So the story starts with Fukushima in 2011. The Japanese asked for help to treat the water, and therefore Veolia experts proposed their ideas and came up with a solution. As you can see, in 4 months, a solution has been proposed, put in place, and installed. And then the treatment of the water started. So thanks to this experience, Veolia continued to develop prototypes, studies to make this system more and more efficient. So this is a Jack turn now.
Yeah. So this is the vision of Veolia for contaminated water treatment technologies available from, for instance, different cases of use such as high contaminated coolant treatment on the right of the slide, and also medium contaminated water such as groundwater or surface water. In order to adapt to a lot of events, the proposed solution is based on a modular approach. Each model, in fact, is designed to ensure a function. For instance, cooling, ensuring power supply, adding chemicals, filtering, or removing soluble isotopes. We will see more in detail some of these functions after. To respond, the setup is developed in line with expectation and use case constraints. And in fact, that leads to a customized solution thanks to this building block approach. So now let's have a look on how does UMTech decontamine water. There is 3 different blocks for radioactivity removal. The first one is filtration. Filtration is dedicated for solid removal contamination, and the other ones are devoted to soluble contamination, medium or high range, by the use of adsorbents, a large variety of adsorbents. UMTech here, this system, involves a dynamic treatment over time on a closed loop connected, for instance, with a building, with a reactor building. First, of course, high radioactivity is treated using what we call a high-range cartridge. We will see that, you will see that later. And then the operator can switch to conventional cartridge when radioactivity level has decreased significantly. Of course, also filter cartridges can also be used depending on solid concentration. One important parameter to follow the process performance is the decontamination factor. The decontamination factor is a ratio between the initial activity of the water and the remaining activity. UMTech process is designed to reach a decontamination factor of 1 million in 4 months.
So this is the project we call UMTech. UMTech means mobile unit for decontamination of the water. So the story started with the ASN, the French Nuclear Authority, was requested EDF to propose a solution in case of a nuclear accident. So VNS proposed a concept, and this is the overview of the system. And this project has been started in the VD4 program. It is part of the decision taken after Fukushima accident to implement this case of this kind of system in for the nuclear reactor fleet in France. So this is the timeline and some key figures of the project. So as you can see, the story started with Fukushima in 2011. Then Veolia continued to develop processes and to make the process more and more efficient. Some tests, some prototypes have been put in place by Veolia. And then the inquiry from ASN. So Veolia spent a lot of energy to convince partners, and our important partners, Real and Cegelec, in this project. Together with them, we proposed to EDF an overall project. Then, in between 2021-23, basic design or preliminary design have been put together, and today it's an important milestone as the signature of the contract is going to be tomorrow at the EDF booth, and this means that we have now 2 years ahead to finalize the project and to go up to the final design and final acceptance testing of the unit. So as you can see, the target is delivery early in 2026. So just a few key features. So the installation has to be in less than 3 months. It's a fully transportable system. So it consists of 5 skids and cartridges that can be transported by trucks. Decontamination target is 1 million to be achieved in 12 months, as Jacques said. To operate the system, it will require about 100 operators and for 12 months of operation. Obviously, this system is fully compliant with high radio protection constraints, and it's based on Veolia cartridges and process technology.
So now let's speak about the concept, the system, system concept. The system is composed of several skids, as you can see here. Each skid is is designed to ensure a process function, cooling, and so on. And in addition, one more thing is a region skid designed to adjust water composition, such as pH, boron concentration, and things like that. Columns here are single-use replaceable columns. They are plugged on the treatment skid using quick connectors and so that they can be easily set up and removed. Each cartridge is, of course, controlled, tested, and adjusted before use to ensure the safety of this operation. And all bricks, of course, are designed to be dispatched by standard truck transportation. That's an important point. So now one historical point for the design of these equipments. Here you can see the evolution of the standard cartridges. These were this used in Fukushima to the last design. With this configuration, in fact, media capacity are generally high, so that the activity loaded in the cartridge is too large, depending, of course, on water concentration. And that leads to several technical issues. For instance, temperature rising, radiological hotspots, and also radiolysis management. Based on this observation, development of this specific column has been performed. And this can be summarized in 2 main steps. First one, creation of an internal core to dissipate temperature. But this is not enough to remove hotspots. So the next step was to develop a multiple injection system to distribute activity all along the cartridge and use the entire volume of the cartridge. This allows, of course, to reduce hotspot, optimize the activity loading, and as a consequence, reduce waste generation. Furthermore, this design is also developed to ensure what we call auto ventilation after draining. That means that there is no issue with hydrogen since you control the loading of your cartridge. Thank you. To move from concept to industrial solution, we have used multiple knowledge of Veolia on decontamination processes. Knowledge on adsorbents and the affinity for elements, isotopes. Knowledge on hydraulic behavior by performing, for instance, CFD calculation. And This applied to filter system and for sorbent bed. Sorry, knowledge, of course, on activity emission and on safety to ensure safety of operators. All this was done to perform a first prototype and to validate this prototype with our partners. Once this concept has been validated at prototype scale, the development goes on with the industrial development. I'm sure it's not a surprise for you, but that's the logical way. Its goal is to reach the design which fits with performance and industrial constraints. That's the phase we are in the project now. This part involves different partners and needs several design iterations, such as seen in the previous slide, to come up with the final manufactured equipment. It's again for me. We need, of course, to control this process. One important feedback from Fukushima was the monitoring of the cartridge loading. And this point has been taken into account at the beginning of the project. And what we can say is that a specific tool is under development to predict ion exchange and the activity related to this ion. The goal is to estimate as possible and as precisely as possible, the activity removal element by element and calculate in real time the decontamination factor. It's also useful for operators to manage the cartridges, loading and replacement. Furthermore, an expert mode is also under development. Its aim is to elaborate different scenarios, for instance, adsorbent choice, cartridge choice, which kind of cartridge, I mean, and evaluate decontamination, predict decontamination over time. And that helps for the management of the whole process, of the whole operation. Of course, to do that, we need to control, we need to measure, activity and in each step of our treatment. For that purpose, as you can see here, online gamma spectrometers are designed to take place into the treatment skid, directly into the treatment skid, and they measure continuously the composition of the water to be treated and the contamination of the water of the treated water. In addition to that, a sampler system has also been developed to ensure to allow the punctual analysis. The aim of this radio element tracking, in fact, is to focus on the main contributors, not all the elements, but only the main. We need to adjust depending on the source term.
So, as a conclusion of this presentation, let's say that this project allows us to make a step beyond in this kind of system for a groundwater treatment issue. So mostly it allows EDF to respond to ASN inquiry with a reliable, efficient, easy to install system. Versatility and safety for operators is also one of the key features that has been taken into account for development. We believe that the technology proposed by Veolia of the cartridges, combined with the performance processes system, is the key features for such a system. And at last but not least, we put together a partnership with very strong partners, such as Real, Cegelec, AIMCO, and some more. And we think this is a great human adventure that has just started. So let's continue, and thanks all of you for attending this presentation. If you have more questions, you can pass by at our booth, Veolia, and thanks very much.